Welcome to another No Name Box Mods video. Today we'll be building one of the MOSFET part kits. It comes with two MOSFETs, and I get a lot of questions about why it comes with two. This lowers the voltage drop on the device when you're actually using it. So here's the kit as you'll get it, and the enclosure that comes with it. So I'll get out the parts here and go over them real quick. Of course, throw the business card up there. First off, we have the Dual-18650 Keystone battery sled. This is nylon composite and they're pretty sturdy. I stock all of my kits with these kind of battery sleds. One, they're a lot easier to modify in my opinion, and after they're modified they hold up pretty well. So let's go to the rest of the parts here. This is not a standard kit, I should note. For this build I'm going to be using some of the extra options. That includes this black 510 connector. And to give you an idea, that is the stainless steel 510 connector. And then I also have an option for a copper one. But for this build I'm going to be using a black one. We also have the fire button here. This is a nice raised button. It's got a good throw to it. Very comfortable when you're using it in the box. Also has screw-on terminals, which is kind of nice. The MOSFETs in the kit today are the PSMN1R9. These are equivalent to the IRLB 3034, IRL 3034B. They have all the same specs, it's just sometimes you can find some and not others. So that's what I have in stock at the moment, but they very well could be the other one. This is the 15K resistor. It's the blue one, it's the only one in the kit. We also have a lockout switch that we'll put in line with the fire button, so you can put it in your pocket without worrying about it firing or anything. It should be noted that that's not a master on-off switch, so we'll not cut all of the power to the box, but it will keep it from firing, which is nice. And we also have two 15 amp resettable fuses. Those are very tiny. I guess I could try to zoom in here a little bit. There we go. So two 15 amp fuses. And move that up a little bit. Also, the kit comes with 4 grub screws. These are helpful for getting the magnets to stick to the box. And they go right into, I'll go over that in a second, but they go right in the same screw post. And then for this kit, we're using the black epoxied neodymium magnets, and those will go in the lid. As for the box, this is a recent addition to my inventory. These were specially powder coated. Zoom out a little bit here. I had these specially made. This is also an extra option. Normally the standard kit comes with, had all this stuff ready, but standard kit comes with a 1590G black box. There's also options for several different colors. I believe I have orange, purple, vintage blue, powder blue, cream, military green, seafoam green, red baron, a bunch of different colors. And you can also get it with the larger 1590B box if you do not feel comfortable building in the smaller version here. Find a screwdriver here. But these ones, like I said, I had specially made, so I figure I would take the opportunity and record a video building one with it. As you can see, the grub screws that I was talking about screw right into these posts. And after we attach the magnets, it'll line up and seal on there pretty good. So next we'll talk about tools. Okay, so in this section I'm only going to cover the metalworking tools. That's for modifying the box to get it into the shape where you can put it in, put all the parts in. When we get to soldering everything up, I'll go over the tools that you need for that. So it shouldn't be too long of a video, hopefully. I would say these are probably the bare minimums for metalworking. You're going to need a drill, a 1/4 inch bit to drill out the lid for the magnets. Go over that one in a second. This is a step drill bit. You can use larger drill bits and drill out the holes for the button and the 510 connector, but I find this to be infinitely easier, and it is kind of hard to find drill bits that will that large that will fit in a normal drill. So you can pick up like 3 of these for like $8 or $9 at the hardware store. They're pretty cheap. But we'll be using a 1/2 inch hole and a 7/16 hole to drill the 2 main holes in the box. Also, I threw in the Dremel because it's kind of related, but this will be pretty integral for modifying the battery sled so it fits in the box. I just have this simple barrel, I don't know, cutter I guess is what I would call it. Works well on aluminum and on the plastic. As always, definitely have some safety glasses. You know, it's not really worth getting metal in your eye or anything. If you're ordering the voltmeter with this kit, it is a little bit more complicated, but you just need a couple other things to go with it. These are the 3 or 4 main things I use to cut the slot for the voltmeter. It's just a flat file, a square file, a smaller drill bit to get it started, and then just to make some quick cuts so I don't have to drill it all out, this cutting wheel. It goes through the aluminum just fine in my opinion, and I use that in the Dremel. So that's the basic tools you need. If you're doing sanding or finishing, obviously you need that kind of stuff. If you don't have this melange of tools, I mean, this is easily more than the cost of the box. I do also offer a drilling service, and here is an example of a drilled box for a Raptor actually. So it's got the extra holes and the voltmeter cut, and these are drilled out. And when you order a voltmeter option, I also remove this post so you have plenty of room in here to build. For just the standard MOSFET kit, that's only $15 without the voltmeter, 25 with. That's a little bit extra work, so I charge extra for it. So if that's a stopping point for you, it's not too much for what it's worth. If you're going to be doing a bunch of these boxes, though, definitely get these tools. Makes it all a lot easier. Okay, so let's talk about drilling. On the product page, you'll find this printout here. There are 2 different printouts, one for the voltmeter, and that's not on here, but I'll show you exactly where to do it. So some things to note about this. When you print this out, don't print it out in your browser. All the browsers like to add margins, and it squishes the PDF document, and then all the scales will get out of whack. So when you do print it out, you want to check the scale up here in the right hand corner. That should be a 1 inch square. And as long as you get that, then these will work out perfectly. So what I did here is I created these in a special graphics program for scalable vector graphics. pretty easy to use. If you'd like to download the scalable vector version, you can, and that means you can edit it and move stuff around if you'd like. If you don't like where the button's placed or whatever. But I think I have most of the options covered here. Where the button is here, it keeps it out of the way of the battery sled for the most part. And then you have the option for a centered 510 or on either side. I don't generally recommend putting the 510 connector on the same side as the button. They tend to really get in each other's way, so I'd advise against that. But for purposes of this, you'll notice these center lines are kind of offset, and that is to account for the thickness of the lid. So it's just a little bit to the right, so it centers up with the lid on. That was intentional, and you'll just want to drill whatever size it says, so a 1/2 inch for the button and 7/16 right on the X's. When you cut these out, cut outside the black line. The black line is included in all the measurements, so you don't want to be shaving off any. It won't be that big of a deal because these aren't too precise, but you know, it's just coming down to it. So on to how I do this. I think for this box, and since it's the fancy, I already scuffed it, great. Since it's the faded one, I think I'm going to do the black at the top of the box and just protect this a little bit here. So what I've done is I have this little, what I call the finger breaker hammer. And since I do so many of these boxes, I've made templates, and these, they're just made to fold around the edge, and it's the same exact thing as those. These ones are for my Raptor, obviously, but they work just great. So normally you'd cut those out, and what's really nice is the alignment is pretty much automatic. So I have one already cut out here. And these dashed vertical lines on the sides line up with the inside screw post, so you know it's perfectly centered. And you just do that on both sides. If you don't make templates like this, what I suggest is just get a Elmer's glue stick, put that on the side and just stick it on. It's temporary, it washes off real easy, and I don't know, it works great just for holding it on there for the second while you have to drill it. So we're going to start off and mark these. So I'm just going to put that on there, line up the punch, give it a tap, and these similarly lines up right there. And so now we got those pretty well marked. I'll make sure that lines up. Yeah, that's pretty good. Next up, we have to drill out, the first thing I actually drill are the magnet holes. And for that, I use a drill press. It's a lot easier, and I don't worry about too much going through it. It's a good idea to grab your magnets. That's what I'm doing here. So grab your magnets while you're drilling, and then you can make sure they end up pretty flush with the top of the lid. So we're gonna tilt this over here, and hopefully I'll be able to edit this so you don't have to watch it sideways. So this is the 1/4 inch drill bit going into the drill press here. Again, you could just do this with a hand drill, but since I do so many of these, I have this. And I line them up. Another handy thing here is this brush. So that's the hole we drilled out, and test fit, I just slide the magnet in there. And amazingly, I got it about perfect for this first one. So I'll just go through the rest of those real quick. Alright, so just go around, test that they all sit flush. Alright, that one sticks up a little bit, but that one's good. And if I did it right, perfect. Alright, so that's the lid drilled. And I'll tilt back over here. Alright, so one thing I didn't mention in the tool part is generally this whole work area that I got here. So this is just a bench vise, it's the flat kind, which is kind of handy. Again, worth it for me because I do a lot of these. I think you could get away with some clamps on your bench or something like that, or just holding it by hand, which isn't as safe. So basically what I got here is a 3/4 inch piece of MDF. I bought a big piece and had them cut it down to 2x2. And you'll see the other piece when I bring out the soldering station later, but it's kind of nice because it lets me swap out between my two different workspaces and kind of conserve space. And then I just drilled some holes from the other side to countersink the bolts that hold these in. These are actually just finger tight, and I can take the vise off and clean it if I need. So there's that. Next up, we drill the holes in the box. So get these lined up here and grab some cardboard. You really want to make sure this is all clean before you stick your nice powder coat box in there. No sense in scratching up before it's even done. So that goes in there. And we're going to clamp this down vertical like. Nice and solid. Next up is the hand drill. And I'll plug that in here. So the first hole we're going to drill is the 7/16, and if you buy one of these stepped bits, it's like marked on the side here. I think I have successfully worn mine off. Some people pilot holes for these. I don't really find it necessary. This thing's pretty sharp, and I'll go through it, as you'll see here in a second. So just line it up. If you're using the template, same thing, it'll just tear right through it. Alright, so don't really have to be too careful with this one. You know, as you can see a little ring of the aluminum there. What's kind of cool is the 510 connector easily covers that up, so we don't have to worry too much. Same goes for the button actually. It has a flange on it. So as you can see, that'll sit right over that. Don't have to worry too much. Next up, we do the buttonhole. I like to empty out the little bits first. Clean off the vise here. And set it up again. Alright, so this is going to be a 1/2 inch hole for the button, as you'll see on the drill sheet. So it's always so hard to do with the camera right over it. There we go. And again, I over drilled a little bit, but like I said, the button will cover that up just fine. There we go. Looks good. What's nice about these MOSFET boxes is that's all the drilling you have to do. Those 2 holes and the lid, and everything else will be taken care of. So that's it for drilling. Alright, next up we're going to modify the battery sled so it just fits in here a little bit better. So you can see kind of from the picture here, there's a lot of wasted space, and we'll need some of it up here for the 510 connector to come in, and some over here for the button to get a little bit of relief. So we're going to start by pulling out these battery contacts, which we'll also have to modify. Pull those out real quick. Alright, the general idea is we're going to notch the battery sled down here at these corners, just so it sits back in between the posts a little bit better. And then we'll just take a little bit out of the side here, so the button, just to kind of give a pictorial of this. So the button has a little bit of relief right there, and it should sit pretty well. And then we don't have to take out that screw post, so which is kind of a pain and not very much fun. Also, since I already scratched it up a little, I put some painter's tape on here in case I got any little metal bits hanging around. So safety glasses on, and we're going to use the Dremel with the barrel cutter on it to do most of the cut down on this. Now that I just cut off those little connectors that allow it to stick to like a PCB printed circuit board or whatever. So I'm just cleaning those up. Yeah. Kind of like an idea. Alright. Gotta say, I hate that stuff. So I feel pretty confident that's gonna fit in there. Maybe trim it up just a little bit more. Should work. Alright, so the bright side here is there's still a little bit of gap, and that's kind of helpful because on the inside rim here we have this lip that keeps the lid in place, and that'll give that a little bit of room for relief and don't have to worry too much about the batteries coming in contact with anything. So that's kind of what we're aiming for there. And I'll sit off a little bit to the side, about like that. Next up, we're just going to put a little barrel notch right about there, just to give the button a little bit extra room. I think that'll work out pretty good. Why can I never find stuff when I need it? There, I'll just use this. Just clean up these edges a little bit. About like that. Alright, so do a little test fit here. Stick the button in. Still not quite clear. So we can either chew back this corner a little bit, or we can just put a little bit more relief in it. Probably do a little bit of both. Let's see how that handles it. Don't want to cut away all of that because that is the plastic that holds the 510 connector, or not the 510 connector, the battery contact in. So I took out a little bit more of that. And I think I can live with that. The wires will just kind of go out the side there and should fit fine. And then just check clearance on the 510 connector. It should give us just enough room to connect the positive wire. So there's that. Put that aside. Turn Try not to brush away my battery contacts. Okay, next up are the battery contacts and how to modify them. Let's start off with these are just some vertical cutters, and I just trim off that that little bit of a tail right there. I think you can actually just break those off. Yeah. So you don't have to ruin your wire cutters doing that. Now the next part I use a little tiny bench grinder for, but if you don't have one of those, you can just use a little bit of sandpaper. I'm going to grab that here in just a second. This is a very tiny bench grinder. I like it. I use it to sharpen my knives occasionally. So what we've got to do here is when these battery contacts are in the sled, they go down to the bottom, and we don't want them coming in contact with the box, or that'll create a short. So what we're going to do is grind down, see if I can show it here. These little fins that stick up, we're going to stop a little bit before that. Taking off probably 2 or 3 millimeters, if I had to guess. So just hold them in, some pliers. Alright, so that's still kind of hot. Make sure this is focused. So you can see kind of the difference there. Just took off a little bit. And that'll just make sure we don't ground out or anything. So do the rest of these real quick. Alright. And the final modification we have to make. Fortunately, these battery contacts are meant to be like you put the batteries in and never take them out. These battery sleds are typically used on things like backup power for routers and appliances like that. So they have this flat connection right there that just goes that way. And if you leave it like that, it's going to tear up the wraps on your battery, and I think I don't need to explain why that's bad. So what I do is take my needle nose like this. You want to line up with that crease right there and just kind of get a good grab on it. And then if you put it onto the table and bend it, you end up with a nice little 90-degree right there. And that'll keep you from tearing up your battery wraps when you take them in and out. Consequently, when you're removing your batteries, I don't suggest putting a ribbon in. I've seen some people do that. The best way to take them out is to start at the negative end of the battery. It seems to be the least damaging method I've found. Get these all bent. And then we just put them back in the battery sled. just pressing them flat there. So to demonstrate the difference, I'll grab another fresh battery sled and you can kind of see. So we got that little gap at the bottom. We don't have to worry about it shorting out. I trimmed off those tails. And we notched the corners, so you can kind of see. Yeah. And then we took a little gouge out of that corner there where the button goes. And obviously if you're building the wrong-handed version, i.e. not the right-handed, for all you left-handed freaks out there, you would do it all backwards. So there's that. Alright, let's talk about soldering this all up. So we got a pretty good spread of tools here. So it's pretty basic to what you're going to need. Go through some of the materials first. It's got some 18 gauge wire here. You can go down to 16 if you want. I like this stuff because it's got a pretty high temp coating on it. I forget the brand, but that'll be the main power for our box. Also have some thinner 22 gauge. I just need a little bit of that for the button and the lockout switch and a couple other things like that. Solder, got some 6040 rosin core solder here from Radio Shack. I don't know if they're still in business. I don't think they are. But you can see how long that's lasted me, obviously. Solder flux. This stuff is really important for getting good connections. This stuff right here by MG Chemicals is kind of expensive, but totally worth it in my opinion. It's about 10 bucks for a tube of this stuff. Great to have around if you plan on doing a lot of this. As for tools, I got a wire stripper here, very helpful. Diagonal cutters, not completely necessary, but if you need to like trim off wires in small places and stuff like that, they're good. Really like these curved flat needle nose. Just good for wrangling around parts, getting into the tight nooks and crannies of the box. So I always use these. I just picked these up today actually. They're 4 bucks. Before I was using these cheapies from Harbor Freight, so I splurged a little today. Also helpful, pair of forceps, just ranging wires and kind of nudging things around, picking up small parts like soldering on the resistor and that kind of thing. Obviously you're going to need a soldering iron. This again is a cheap, what is this, a 30 watt or something from Radio Shack. This will get you by. It's not the best. My choice of soldering iron, I'll show you here, is the Hacko FX888D. This is a $90 soldering iron, and in my opinion it is completely worth it. I use this thing every day and is probably the best soldering iron I've ever owned in my life. It has digital temperature control, and what that means is it actually has a sensor in the soldering iron that adjusts the amount of electricity going to the heating element and keeps it at a constant level. And you can set it with a little interface on it. Totally optional tool, but I find myself using this thing all the time. About 19 bucks on Amazon, I think it was. This is an automatic wire stripper. This thing saves me so much time. I love it. Also, you can kind of see it here, and if you've watched my other videos, you're pretty familiar with it. This is El Squido, and what this is, got another piece of that 3/4 inch MDF, and drilled some holes in it. These arm things are actually for blowing air onto drilling or CNC machine, or blowing or spouting out, whatever you want to call it, cutting fluid. They also work great for these positional arms. And what I got here is just some alligator clips. I don't even have them attached, but a little bit of heat shrink tubing on the teeth to keep it from chewing things up, and they work great. If you want to get some of these yourself, I think the easiest place to get them from is SparkFun. All told, they have the alligator clips and some bolts to kind of keep them held together, and the arms, and I think they're like $3 each or something like that. They're super cheap and totally worth it. I get a lot of emails about this specific setup because it looks so ridiculous and people want to make their own, so that's how you do that. Alright, so that's tools. Oh yeah, one other thing I always forget to mention, very helpful but totally not necessary, is a heat gun. This is way better than using a lighter to shrink the heat shrink tubing. Way safer too, and you don't risk damaging your parts. So that's about it for that. Alright, let's start soldering some stuff together. First thing we're going to do is take care of the MOSFETs and just put some leads on them. So we got the two MOSFETs and the 15K ohm resistor I just dropped. To be able to fit all of this in this smaller 1590G box, what I do is lay these on top of each other. You absolutely do not want to put them back to back like this, and especially if you connect all the pins together. That would be wiring them backwards, and your mod would automatically fire then. So what we're going to do is just kind of lay them over, and then we're going to bend these pins down to meet these. We'll solder on some wires, and we'll get the 15K ohm resistor connected. So first thing, this is probably like kind of cringy moment, but I'm going to trim off just up to this thick part here, the leads on the bottom one. That'll look good. I should really silence my phone. Alright, and so these don't quite match there. So we're going to do is kind of start bending them with a measurement there. And I always forget to make sure this is in the camera shot. Kind of know where they need to bend at, and just tie them down a little bit. I go a little bit further than what they would bend to, and then we can just kind of bend them back a little bit so they're flat. This will help get a good connection onto the leads of the second MOSFET. You can kind of see that there. And just kind of even it up with the needle nose here. That'll be trying to think where the camera is. That'll be a good connection. Alright, so I'll get these clamped in. Really want to make sure these are well positioned before I start trying to solder them all down. Just trying to meet that up there. I think I'm actually gonna grab a different clamp here. That's not gonna work very well. try one of these finger clamps. Alright, that looks good. Try to support this a little bit. Let's see if that's a good view there. Alright, that's going to work very well. One other thing to note is we should put some flux on this before we start soldering. So this is just kind of like a pick or something, and I'm just going to put a little bit of flux on each contact. This cleans the contact a little bit when you heat it up, and it also makes the solder flow a little bit better. So it kind of like sucks it into any gaps and helps you out in that kind of respect. Fortunately, I have not made one of these boxes in about, I want to say 4 months. So I'm a little rusty here. Alright, that looks like got it good. Alright, clean off the soldering iron and just need to dab a little bit on. The other advantage of these arms is I have kind of shaky hands, so I often use them to kind of rest my hand on when I need to do something delicate. Now we don't want to put too much heat on these. Right now I have my soldering iron set at 650 degrees, so don't have to worry too much. Got some good contacts. Next up is going to be the 15K ohm resistor. And how you connect this is mostly a matter of taste, I guess. What I'm going to do is arrange it so it's back here by this tab and it doesn't stick up much. So we're just going to put a 90-degree bend in the lead. And if I'd measured a little bit better, probably would have come to discover that that was a little too wide. You got to be careful with these resistors. You only get one in the kit, so you don't want to sit here and bend these leads back and forth too much, or you will break it off. And ordering another resistor from Mouser or something, it's not fun because the lowest amount they will charge you for shipping is $4.99. And when you're talking about a 15-cent resistor, that isn't so great. So we're going to place it about like that, and then we just want to get these leads bent back over. And if you look on the schematic, notice that they get attached to what is it, the gate and the source, so these two outside pins. And this will be what keeps the just going to bend those back so they're in plane, the two pins. This is what keeps the MOSFETs from supplying voltage to the 510 connector. So, pretty important part, unless you want your mod to always be firing. So we got the resistor pretty well shaped. That's kind of what it's looking like here. Just gonna clamp that off for a bit. smear a little bit of flux onto these leads. And this is kind of the part where these forceps come in handy. Just want to make sure we get good contact between the leads. I think it's laying on there pretty good. So it might not look like I did much there, but thanks to the flux, it sucked the solder down in between the two leads, and I'm pretty sure it's a good connection. I just want to move this one over a little bit. Not something you want to hold with your fingers for obvious reasons. These things conduct heat quite well, and you will burn yourself. I'm just gonna let that cool for a quick second and check it here, and it looks like got a pretty good bond. So we're just gonna take that excess lead off. That's our little MOSFET package. Next up, I'm gonna flip this over. And this is important to keep in mind when you're looking at the diagram. So this is ding, ding. Alright, now we're gonna just kind of rough cut some wire and tack it on and get everything heat shrinked. I usually just kind of guesstimate with this, but any piece of wire that's going to be longer than the box is going to be fine. Whip out these magical wire strippers. And occasionally I just have to clean it up a little bit. So what's great about this wire is it's kind of expensive, but it comes pre-tinned, and this I don't know what you call that, the shielding, not the shielding, the insulation on the outside of it is pretty high temp. And we don't want exactly all that much hanging off of there. So I'm going to trim that down just a little bit. And pull up a hand rest for myself. And this is going on the right one, and that is the source. That'll go back to ground on the battery sled. And just double check that. Good solder connection all the way around. Doesn't look cold. Looks pretty good. Next up is the drain, and this is what will go to the negative post on the 510 connector. Again, doesn't need to be that long. And each of these wires, I'm dipping in flux before I attach them. Keep that in mind. I'm basically just letting the wire not get attached. Letting the wire soak up the solder and get connected to that pin there. It seems to be getting away from me. Again, we don't want to apply too much heat lest we risk burning out the MOSFET. And like always happens in these videos, I did not do a very good job soldering that one. That's why you want to double check. The other thing you risk is getting too much solder, which will be troublesome later when we try to apply some heat shrink tubing. And the last one we'll connect is some of this thinner 22 gauge red wire, and that will be the gate, and that will be what triggers it. This doesn't need to be high voltage or anything. Nothing important is going to be running through it, just the logic gate. So this wire doesn't happen to be pre-tinned, so we have to tin it. And it basically just consists of sticking it in flux and putting a little bit of solder on. Now again, that lead is just a little bit too long, so I'm going to trim off just a touch, dip it in some more flux, and attach it. Pretty positive that was a good one. Pretty positive, no pun intended. Alright, so that is the rough shape of our MOSFET package. Now, what I failed to include in the introductory part of the video where I talked about the kit was heat shrink tubing. And helpfully, this kit does come with an assortment of sizes of heat shrink tubing, which we'll use here. For these, we're going to trim down a little bit and place it over each one of those connections. Probably not totally necessary, but I like to be safe, and it makes it look clean. So I'm just going to slide those down. Spread this apart a little bit. There we go. I'm going to hit that with a heat gun. All nice and fancy. And then there's also this other kind of wider heat shrink tubing, and that is for the actual whole MOSFET package. Should slide in just like that. I always try to include a little bit extra. You really want to make sure you insulate these tabs. If this tab grounds against the metal enclosure, it will fire the box. So that's a little troubleshooting tip there. If you don't have it properly insulated, your box will auto fire. And we don't have that connecting to that. Looks pretty good. Just kind of measure this out. And here's my scissors. So I leave a little bit hanging off the edge there. And about like that. Hit it with a heat gun. And just as a little extra added step, while it's still hot, I grab it with the pliers. Just kind of crimp that end. Makes it look neat too. And then you can just trim a little bit of that off. And that's the MOSFET package. Next up, we're gonna solder some wires onto the battery sled, and since this is gonna be a parallel build, we'll jump negative to negative and positive to positive. And I always put the positive up at the front because that's where we're gonna end up connecting the 510 connector to. So that makes it a little bit easier. Let's get started here, I guess. So again, we're gonna need some wire. Get just a short bit of this. I'm gonna bridge these together. It's kind of tricky measuring this, but let's start off by stripping some. So we got a good bit there. I often have a little bit of trouble soldering to these contacts myself, so don't feel bad if it's hard to get a good stick on it. I think a good way to start is put some flux on the contact. I'll just smear that around a little bit. And just put a little bit of solder on there to begin with. I think there might be some coating from the factory or something on these that makes it a little bit harder. But if we burn it off and just get some solder to kind of stick to it, it's a good start. Keep in mind those contacts are hot now. Let's see here. So we're just going to make a little U shape out of this. Bend it a little bit here. We don't want to go in all the way down to the bottom. Don't want it sticking up too far, so kind of like happy medium kind of stuff. And yep, that's hot. So, lesson learned. And a little bit more bare than that. That's probably too much. Just kind of like try to measure this out. And bend it a little. Maybe a little less than that. Okay, that looks good. So let's get some flux on this, and that will help a lot. And at first, I just like to tack these down and then go back and kind of glob on the solder. I use the forceps here to kind of help it out. These are stainless steel, so the solder doesn't really like to stick to them too much. There we go. Turn this a little. And I've done this practically completely out of the view of the camera. Wow. Alright, so going back, put some solder on, put some flux on, put some solder on the contacts. Definitely going to show this on the other one, so it's pretty much the same. My bad. And tack down it on one side, and then we'll do it on the other. I should get a monitor down here so I can have kind of like a heads up on but I'm not shooting very well. This is one of the points where that really high temp insulation, yeah, that's the word, keep forgetting it. It's really helpful because if you buy cheap stuff, it will just kind of melt at this point. So we're applying a lot of heat here. And I'm going to let that cool down for just a second. Yeah, I can see it's pretty solid. Still very warm. Alright, so I'm just going to repeat all of that again on this side, but with red wire, because that's going to be the positive. And if you get a piece of wire pretty much the width, a little bit longer than the width of that, it works pretty good. So again, since I haven't watched the recording yet, I don't know if it covered it very well, but flux on here. And we'll dab some solder on to kind of tin these, as I guess we could think of it. Let that chill out for a second. Strip off this wire here. Probably don't want too much more than that down in there. This one we gotta leave a little bit of room to connect the other wire that goes to the 510. So we're gonna have to solder another wire this size on there as well. Trim off a little bit of that. And check the fit. Looks pretty good, that'll squish down. Get some flux on them. Alright. Let's try to tack these down. That was a good one. That one, not so much. Alright, and that'll work. So that's our parallel battery design. And it looks like the solder spread out and both connections are pretty solid. Let that cool off for a moment. And next, I like to kind of pre-wire up the lockout switch, and that's not as complicated as it sounds. Something to note about these switches is there's a side with 2 holes on it, and that goes directly through to the switch. So if we glue that side to the wall of the box, the epoxy is going to get in there and it's probably going to freeze the switch up. So even at this point, I'm already thinking we're going to glue this side to the box. And that's kind of important to keep in mind, I think. So these 2 outside pins on this specific switch, I do change up these switches occasionally depending on availability and stuff. But these 2 outside ones on this tiny switch, you can just clip off. And they are just there for mounting purposes. And then I trim off one of these because this is a single pole double throw switch. And just take that one off. And that leaves us with an off position and an on position. So off, on. And just to kind of make it a little bit easier on the wires, I bend these pins to 90 degrees. Gotta be careful because they are kind of flimsy. Just take care of that. And I'll just throw that in a clamp. And at this point, we're just gonna solder on one wire. So this wire is going to go to the button, so it doesn't need to be too long. And we'll tin that up. That is kind of long for that little contact there, so just trim it up a bit. Get some more flux on it. And tack it down. Okay. And then just a little bit of heat shrink tubing. Better safe than sorry in my opinion. Also kind of reinforces that pin a little bit so it doesn't break off as easy. Okie doke. So yeah, that's just a simple little thing. Next up we'll do the positive pin on the 510 connector, just to kind of get it out of the way. A lot of people kind of sweat over this. It's not too complicated in my opinion. First thing we're going to do is clamp. So this is the center core out of the 510 connector, and that is what screws into the Delrin piece, and that Delrin piece into the flat part, the body of the 510. So that all goes in like that. And the Delrin keeps it insulated, and here we go. So I'm just going to cut off a piece of wire at this point. Doesn't need to be too long, 2-3 inches. Putting this all in here, it only has to go like that far, so a little extra. And let's see here. So the real trick to this is, one, you don't want to solder this center piece that's kind of spring-loaded to the outside collet. If you did that, it would no longer be spring-loaded, it would be frozen in place. So the simplest trick to this is get a little bit of flux and stick it inside the pin. We don't want it anywhere else. Just kind of goop that around in there. So that's set. We're going to strip off some wire. Now, I know from previous experience that that is going to go in all the way, and that makes it a little bit harder to solder. So I'm going to intentionally make the stripped part a little too long, and we'll see that it sticks out a little bit. Twist that together a little. So there's that little bit sticking out right now, and that's going to help us. That's where we're going to touch the soldering iron to, and just let it kind of pull the solder right back into there. So get a little bit more flux on that, and kind of get positioned here. Just gonna put that in there and get a good sized glob solder on the iron. Let me clean it off first. So we're just going to touch it to the wire, and what that's going to do is the flux is going to pull it back in, the flux will boil, and kind of hear it there. Just make a nice solid connection. And we can see, burned the insulation a little bit, but it's not too terrible. So we got that little bit sticking out. And I'll just take a little bit of heat shrink tubing, clamp that off again, and we'll insulate that a little bit, just to make it look fancy. Totally not necessary. Alright, so that's good. What's up next? Now we should probably do the fuses now. Still a little warm. So that's going to go in right about there, and we'll end up bending this at a right angle, and we'll end up connecting to probably that one. It's a little bit easier. So in between there and there, gotta hide some of these 15 amp fuses. Now these aren't completely necessary, so if you break them, I don't think I would bother replacing them. If you treat this mod with the same respect and safety that you do a regular mech, I think you'll be fine. Regular mechs don't have fuses in them, but you know, it's not too huge of a deal. So we're going to trim that off a little bit and strip just a wee bit of it. Clamp that off. Dab some flux on. And here comes the tricky bit. Alright, so these fuses, I don't think it's too important that they be in the same direction, but it's probably a good idea. And we're going to put these in parallel. So like one of them, the tabs come out a little bit higher. I don't know if the camera can even see that. So just trying to line them up like that, and we will clamp them in here and drop them. You might wonder, why did he put these tiny fuses in this kit? Because the alternative were these fuses, and two of them at that. So kind of had to weigh the odds. These don't even fit in the 1590G box in any sort of reasonable manner. So I went with these little tiny strap fuses. So you're like, man, why do you put these stupid fuses in here? That's why. These lined up with the third hands. Looks pretty good. And the thing to keep in mind here, I'm just going to disconnect that. The fuses themselves are not soldered together. Probably should have put a dab of solder in there, or a dab of flux. That'll be okay. Or not. Alright, so we gotta put some flux in there. And I'll just put a little bit right there. Turn them back. Definitely not the prettiest thing in the world, but I believe it will work. Looks pretty well bonded. And we're just going to do the same thing with the other side. Obviously, I haven't thought this through very well. I used to just build these without any fuses because it was easier. That should work. Alright, and then we'll just get a short little piece of wire on the other side. Tack that down. Looks good. I think I can live with that. And just to kind of reinforce all of that, the kit comes with some of this thicker heat shrink tubing, which should fit over that just fine. And we'll trim it down so it's not so long. And there we go. We have a nice little fused 510 connector. Alright, that's a lot of the major stuff before we start assembly, so I'll come back in just a second. Okay, so next up we'll kind of start getting this all together here. One of the things we want to do is clip off these tabs on the battery sled. They're meant to hold the batteries in. We obviously want to be able to take them out easily. So I'm just going to kind of trim them off here. You can score them with a utility knife and just kind of snap them off if you want to. I just use my cutters here and try not to get the fragments in my eye. Looks good. Find my knife, wherever the hell it went. You know, I just tried to organize this place too. Yeah. Hiding in my new organizer. So just trim these up a bit. Like them to look nice. Go. Next up, I'm going to attach a little bit of the 22 gauge wire right on there, and that's going to be where the lockout switch attaches. So it's going to be pretty short. Probably want to strip that other piece off too. So I'll tin this piece of wire up. Seriously, not that big. It's got to curl up and kind of all fit in there later. So, fortunately, a lot of this mod building is about experience, and if you're just making a one-off box for yourself, you might not exactly benefit from that. So next up, so this is going to trigger the gate eventually on the MOSFETs, which is kind of cool because I don't know, I admittedly do not know much about electronics. I know what other people tell me, and this works, so I think it's kind of cool myself. Just get that attached on there, and prep a little piece of heat shrink tubing and slide that on there. And we're going to tack that onto the lockout switch. Kind of bend this all into place here. Get some flux on there just so we get a good connection. And apparently I got it on myself too. Right. There we go. Just trim off a little bit of that tail there. Breaking anything. Try to get that other one too. Move the heat shrink in place. Alright, so if you're following along on the schematic, this kind of got to get wrapped right back like that, and that's going to get glued to the wall of the box. This lead is going to go to the fire button, and then the other side of the fire button is going to be connected to the MOSFET assembly. So that's where our fire button will make its connection, and when it's locked out it can't make that connection, so when we switch that up it's off. And this is going to get wrapped around the side here and connected to the battery contact on the negative, and this is going to go to the negative on the 510 connector. And then after we get all of that together, we're going to connect positive 510 to the positive terminals on the batteries. And that should work out just dandy. Right. So I'm going to start bending this into kind of the shape that we need. I got to be careful here because these are attached to those leads, and we don't want to break the solder if it's a little too weak or anything. So that's going to come at a right angle down here. And if we throw this all in, you can kind of start to see how it's going to fit. Still need to clean that up some, jeez. Sorry, usually I pay more attention to this stuff. Alright, I can live with that. So that comes down the end here. If you're having a hard time, because you got to remember the button's going to be like right here too. If you're having a hard time fitting this around with the post and everything, you can actually solder the wire to the inside of the contact there instead of wrapping it around to the back. Which we might have to do in this one because I didn't leave too much room here. So that's about the gist of it. I think I might end up doing that. And this middle one here, the drain, it's going to get pretty much bent back at a right angle. I actually like to have the positive over that one. So it's going to get bent back. And we can see from kind of where everything fits in here. This is going to attach to the negative ring on the 510 connector. So based on where the hole is and the 510 ring, you can kind of get in here, measure, and I'm going to cut it about there. Now that can be kind of a scary thing to do, honestly. Built a lot of these, although it was a while ago, and I know that should pretty much work. The negative connector isn't too much of a problem to connect, to solder on. Really the trick here is the flux, and I like to make sure it gets gooped in that hole there. Try not to get it everywhere like I just did. Everywhere the flux is, there's going to be solder, and that can get in the way of screwing it down. So I'll tack this on here with a good bit. And we're just looking for it to spread out and kind of fill in that hole. Take that off, you can see right there, nice and flat. Just keep everything clean while the flux is still warm. I'll kind of dab that off. It's not very fun to be all sticky and everything. So we can start to see how this is coming together. Let's do a little test fit here. And that looks like that's going to work pretty well. Throw the 510 connector through there and see how that all lines up. throw the battery sled in. This is kind of where you have to start coercing things together, we'll call it. And it looks like it's going to fit pretty well. The only tricky thing left is get that this soldered over here. I have to say, if you solder it kind of on the inside of this contact here, first couple of times you take your batteries in and out, it is a little stiff, so it is better to run it to the back, which is what I'm going to try to do now, even if we have to resolder some things. Try to get a good measurement on this actually while it's still in here. And I'm just going to use my forceps to kind of mark the insulation about where that's going to be. So that's kind of where the mark is. I'll strip off a little bit less than that. And try to get it on there. I think what I'm going to do here is warm this up and just try to slide it over. That seems to have worked. I think there's just going to be barely enough room to fit that in there. And if not, we can just slightly nix some of that insulation out of the way. Doesn't matter too much if these are touching each other, obviously. Just make it squeeze in there without destroying anything. Alright, we're just going to go the other route. Not my preferred method, honestly, but I'd rather it work than not. So again, we'll get some flux back on there. Yeah, this is always kind of a trick. So we're just gonna, the stripped wire is on the inside and back of that contact. And I'm just gonna stick a good glob of solder right back in there and let it soak it up. Yeah, it seems like we got a pretty good connection. Seems like it anyways. Then we can kind of tighten a little bit of this wire up. And it'll end up with something like that. So that all fits down in there. Got our two button wires coming out. Last thing to do is to get the positive 510 connector on there. And then we can assemble it and glue it together. Alright, so for the 510, I'm going to make a pretty sharp right angle bend in this. And it's mostly due to space constraints. If we take a look here, that's still going to be kind of tight. And I honestly should have made that a little bit shorter, but I'm not going to cry about it. So now we have to figure out how we're going to connect the other end of that wire onto the battery sled. It's going to mean probably trim it down about that much. Never claimed that this was an exact science. And just kind of bend that out of the way. So I'm going to try to connect it about like that. Really don't want to melt that wire. Alright, so that looks like a good connection. Now the real trick is going to be bending it into a shape that will both fit in the box and not break those fuses. And I can already tell you right now that's way too far over. So we'll try putting a kink in it. And hopefully that'll work. Just so we don't have to keep taking these apart, this is the nut off of the button. So I like to put that on the wires. And if we get this all in here, then we won't have to try to thread that through, which, like a lot of things, can be a pain. So you can kind of see, if we try to do the 510 connector on the same side as the button here, there'd be a lot of interference. So that's why I suggest offset, or at the very minimum in the middle, although personally I've never built one with it in the middle. I'm sure you could make it work, just be a lot harder. I am seriously regretting putting fuses in these now. That made it a lot harder, but we'll work with it. Alright, so before we try to screw that all together, this is the nut off of the 510 connector, and wherever that went. So, first up, I'm going to put the Delrin in there now. That will make it. And then before we try any of that noise, I'm going to slide the nut in and get it started with the 510 connector. Now, due to the way the drilling template's set up, if you do it precisely, the nut for the 510 connector should lock against this screw post here. And you might just have to pull that out for a split second and get this the positive threaded into the Delrin. Be really careful, the Delrin can strip very easily. We don't want that to happen. So now the Delrin's in, and the way the 510 connector works is the core can spin independent without ruining anything. So we're just going to tighten up the 510 connector here. And the single best tightener I have found is a 1/4. So once we get this down close enough, put a good crank on that. If you want, you can kind of line it up. And then it's just a matter of mashing this all in here. So we're going to try to get the MOSFET to hide under the 510 connector, which is always a chore. And apparently not happening at the moment. So there's a little bit of play in the hole drilled for this. And what I just did there was loosen it up a little bit and kind of raise it up. And that will probably give me the very minimal amount that I need to get the MOSFET assembly underneath that. And we'll just kind of drag that up a little. This is why these forceps are handy. And we just want that to sit down. Get the wire out from under it. And that, in all technicality, is pretty much done. We just have to attach the button, which is also another trick in itself. So to kind of keep the wire down to a minimum, you can pull that out a little bit. Little screwdriver. Button. Alright, so we don't want to make these too short and we don't want to make them too long, because the longer they are, the more cluttered wire there is in there, and it already looks bad enough as it is. So maybe a finger, and we'll strip a little bit off. Don't need too much for these button contacts. Screw the terminal screws here. Get it ready. There we go. This is always the fun part, trying to get it done on camera, so thread the wire in. I don't know how well we can see that. Tighten her down. Now if you want to be extra sure, you can dab some flux down in that hole for the terminal and solder these wires after you screwed them down. Personally, I don't like doing that. I don't know, if you ever have to like swap out the button or something, pretty much cutting out the wire. So there's that. And we're going to rotate this just a little bit so the wires are going out that way. And very gently let these wires fold back in here while getting the nut on. Usually this is where I start swearing. because I never have the best of luck with them. You can get a little bit of extra room here if you pull the sled out for a second. It's a good idea to get the 510 connector and the button in before you glue the sled in. And let's see here. Again, this is easily my least favorite part of assembling these boxes. So I'll start tightening this up. And I'm intentionally keeping the terminals kind of vertical like that. Again, these bent needle nose are pretty helpful for this. And it's pretty tight at that point. I don't think that's going to move around. So we can kind of squish this all back in here. Doesn't seem to be too much stress. And I think at this point we should have a working box mod. It's just a matter of cleaning up these wires a little bit. Just kind of squishing that down in there so the wire isn't straining on the switch too much. May have already broken it actually. But I hope not. Alright, so that's our MOSFET box, and it's just going to be a little bit of cleanup and putting the lid on. So I'm going to pause this and grab some batteries so we can test. Alright, so moment of truth. Get the camera to stop shaking here. There we go. MOSFET box. When we come back, we'll put the grub screws in and get everything glued down and the magnets in. Alright, let's get this all finished up here. So for the grub screws, gonna need a hex key. I guess I should have mentioned that. And what we want to do is get these in there so they are flush with the top of the box. That's the best results I've gotten. So I'm just going to screw those into the screw posts. And depending on the powder coat, I might have to put these in and turn them back and forth a little bit to clean out the threads. Just don't really want to force it. Give that a feel, maybe another turn. The reason I like to make them flush is due to the way I glue the magnets in. Usually there's epoxy that ends up in these holes here, and if that's the case, you want it to sit flush, otherwise your box clicks. So the lid isn't on flat, and it's kind of annoying. Alright, that one's going in nice and easy. You can dab a little bit of epoxy on these if you like. I don't think I've really ever had them fall out. I admit it is a distinct possibility though. That's pretty good. Started carrying these grub screws because people would their magnets would fall out with the epoxy, whether they loosened over time or because it got warm or something. So these grub screws really don't fall out like that. One thing you're going to notice is because we lifted up the 510 connector to get the MOSFETs under there, there's going to be interference right at that. So what I like to do is grab a Sharpie, and we want to make sure we got the matching sides here. So I just kind of draw on this little lip here areas to remove. That should probably do it there. Usually, since I end up gluing the switch to the side, I cut out a little spot for that too. And the other spot is where the button goes. So that's probably going to stick up enough to require a little bit of removal. And then the last thing you want to make sure is there's no contact between the lid down here and the battery sled. It looks like that's pretty flat. I'm not noticing any issues there. So we don't need to remove any of that. Glasses on, and I'll grab the Dremel here. You can do this with a file, you can do this with a piece of sandpaper wrapped around something, pen, whatever. I use a Dremel because it's fast. Alrighty. Don't really want any of that getting in the box. Don't know what kind of problems that might cause. Alright, so that's pretty good. Where are the magnets? So just test fitting the magnets in here. Should be able to see. Get all the dust off. Looks like we got a pretty solid box there. And that's why you don't do that. Okay, just lost 2 magnets. Yeah, don't do that. I'll find those in a second, but I really kind of want to get these metal shavings off my pen. When I come back, we'll glue it all together, and that'll be it. Alright, final step in the build process here. We have some magnets to attach, and we're going to glue down the battery sled and tack this little switch to the side of the wall. Let's talk epoxy real quick. If you're just doing one-off builds, suggest this 5-minute epoxy from DevCon. This is pretty good stuff. Not a big fan of the Gorilla Glue. I find it kind of hardens to a rubbery consistency, which I don't really like. But this stuff dries clear. It's pretty solid, and you can be happy with it. For what I actually use, this is Bob Smith Industries 5-minute quick cure. I like this stuff a lot. It's, I would say, about as good as the DevCon, if not better, and it's really economical in these larger bottles, so that's probably the big reason I buy it. For the epoxy, I just pull out little paper plates. I find they work the best and they're cheap. And if you're doing this a lot, grab some of these craft sticks. They're like $1,000 for $3 or something, and they're nice pointed. You can get in the little tiny places, and generally what I prefer for mixing. Also, for when we put the magnets in, they're really great for holding it in and sliding the rest off. So if you don't have something like this, make sure you have something non-metallic, non-magnetic, that you'll be able to kind of shim in place over the magnet to hold it in. Much past that, let's get started here. Mix up some epoxy. For this, I'd say we probably want about, I don't know, maybe a nickel to a quarter's worth of both parts. Probably end up with a little, but when you're working with this stuff, it's better to have it mixed. So it's probably like a nickel right there. And a nickel again. If you want to avoid bubbles in your epoxy, you want to mix it slow. You whip it back and forth, it'll kind of act like a meringue, if you will. Get this all mixed up here. Bubbles aren't too important when you're just gluing this stuff in. It really matters when trying to cover up the voltmeter, which is what I use this stuff for a lot. So we're just gonna kind of goop it in underneath the battery sled. In my experience, this is pretty well friction fit in here anyway, but if you like the extra security of really nailing it down, it's not a terrible idea. And if you ever have to do any repairs or anything, this stuff does pop out pretty easy. I got a little bit of excess in there. Just flatten it out. And for this setup, I have like, I don't know, some tube or something I had, and that'll just be helpful to press down on the battery sled. And just crank that down a little bit. Next up is this little tiny switch. Really doesn't take much epoxy to get that done. I like to put it on the side of the switch maybe down into the leads a little bit. As far as I know, this epoxy is non-metallic, so shouldn't have too many issues with it conducting. And then when we get it down in there, I want it to be far enough down that the switch doesn't collide with the lid, and just clamp it in place. You also have to be a little careful of the epoxy bleeding over into the switch. You don't want to freeze the switch in place. It's kind of annoying. Next up, we'll do the magnets. And you want to do this on something disposable because the epoxy is going to kind of drip down. So, not really too much to this. Dab a little bit of glue in the hole. Like I said, most of that's going to get pushed out anyway. The bright side of these black magnets that are optional and extra is they are covered in epoxy, and it makes a pretty good bond. So you can see there's I use the wood skewer stick to kind of move the other magnets off, and obviously you're gonna be fighting their magnetism, and that's not good. So we'll just make sure that one goes down. These are pretty strong magnets. I think these specific ones are D42s. Alright, I made a bit of a mess of that one. Other bright side here is this epoxy has pretty good surface tension once it hardens. And if you just take a X-Acto knife and kind of get under the edge of it, it'll flake off pretty easy. It otherwise is a pretty good bond. Get a clean stick. So if you get, excuse me, if you get epoxy on the box or anything, don't wipe it off. Just let it harden into whatever it was, like a drip or whatever, and then just come back with like something sharp and flake it off. Like I just kind of dragged some of that there. And that way it doesn't get down into like the texture of the box, specifically on the black boxes with the texture. It's kind of a concern. I'll just push that in there. And that's pretty much done. When that dries, we'll have a pretty well working MOSFET box. So thank you for watching the video. I think this is going to come out to about 2 hours or so. So that's quite a bit of time investment. I totally understand if you've fast forwarded through a lot of it. If you'd like to pick up one of these kits, please visit us at nonameboxmods.com, and you'll find that under the Dual-18650 kit. You can also find other kits like the Dual-18650, which comes in the larger 1590B box. And I've even been working on a smaller single 18650 MOSFET box in the 1590A box. So those are all wonderful options. This is a great beginner kit. If you're looking for something more advanced with some more power to it, you can also check out the How to Build a Raptor program or movie. Thank you for watching, and have a good day.